Good morning, guys. Today I'm going to discuss about the effects of density when the ship is when the ship is floating in a different density but the same displacement. So let's start, guys. Figure 3.4 says here a ship will float to a different drop waters of different densities when the displacement is the same. Meaning, the ship will float in a different draft if he is floating in a different densities, but her displacement is the same. So you see the figure here, guys. So here he is floating in saltwater density, which is 1.25, but her displacement is 34823. Now on the other figure, he's floating in fresh water of 1.00, but he has the same displacement of 34823 metric tons. So they have the same displacement. Okay. Here, let's start with this figure. Uh, when she floats in 1.025 also water, so the displacement, divide this by 1.025 of salt water density, then you will have this figure of 3397.6. While on the other hand, if she's floating in freshwater 1.00, so the displacement of 34823, which is this one, divided by 1.00, then you will have displacement of 34823. So what will be the draft of this? What will be the draft of the vessel is floating in 1.025, and her drop is she's floating in 1.000. Okay, so with this displacement, guys, uh we'll check this one. Okay, so the displacement, for example, is 34823. 34823. We'll just use the Nara hydrostatic table. So her displacement was 34823. Put here 34823, 34823. What will be her drop in salt water will be 34823. That will be 10652. Okay, so put here 10.652. Put here salt water. Okay, 10.652. That will be her drop here is 10.652. Okay, just remember this one, 10.652. 10.652. Okay, that is 1.025. Okay. On the other hand, if you divide the same displacement of 34823 divided by 1.011, your displacement will be 24823. Okay, so what will be the drop of 34823? So 34823 that will be 24 at 10.652. Okay, that will be 10.652. But on the other hand, the other one is how much? 3397 3397 3.6. Okay, 3397.6, 33973.6. So put here 33973.6. What will be her drop? 10 point 10.1. The drop will be 10.417. Okay, so when it's floating in a density of, let me check guys, 34823. Let's do this by Excel. Okay, so you will also see Excel. Okay, so what's the drop? 34823. 34823, and you have here 1.025, 1.025. Okay, let's make this a little bigger. Okay, then what will be her drop if she floats in 1.025? So equals displacement divided by 1.025. So the new displacement will be 33973.6, which is 33976. What will be her draft? Okay, let's check. 33973, 33973.6. Her draft would be 10.417. 10.417. 10.417. Okay, so that will be her drop. Then on the other hand, we should put this letter A, put this letter B. Letter B, okay. We have the same drop. Copy, copy, paste. And this time we will use the drop of a density of 1.00, okay, which is this one. Okay, this one. So if we use the same drop, the displacement was displacement divided by density of 1.00, and your displacement will be the same. Okay, what will be your drop? 34823. 34823. 34823. Okay, 10.652. That will be 10.652. 10.652. Okay. So with this diagram, when you're floating in one, when the displacement is divided by 1.025, the new displacement will be 33973.6. Okay, 33973. 33973.6. Okay, and his drop will be 10.17. When displacement is divided by this salt water or fresh water, and your displacement will be the same of 34823. Take note, guys, when displacement is uh, divided by the salt water, his drop is 10.417. But when the displacement is divided by fresh water, his drop is increasing 10.652. Meaning, if the vessel is floating from salt water going to fresh water, then the drop will increase. Just remember it, guys. So from salt water, see, this is salt water, and will flow to intensity of fresh water or dark water or fresh water. The drop will increase. This is the drop. Okay, this will be the drop, new drop. So, so from salt water, so from salt water, you will go to dark water of 1.00 or fresh water. Your drop will increase from 10.417 and 10.655. So this is what the this is what the diagram illustrate here. So you will have a change of drop, and you will also have a change of displacement. Okay, so that is what it meant with this diagram. Okay, so from look at the displacement here. The displacement here is less than the displacement here. Okay, but with these figures, it shows that from salt water, this is displacement of salt water. If we go to the dock water or local density or fresh water, your drop will increase. Okay, and your displacement will also increase. Okay, that is what it meant by this diagram. Then we go next. If just read this one, guys. Okay, when the change of density of water is decreasing from salt water to fresh water, the volume of water displacement increases. Meaning, from you go from salt water to fresh water, it is your displacement will increase. So meaning from salt water of 1.025 going to 1.021, your displacement will increase. Therefore, your drop will also increase. So that is what it says here. When the change of density of water is increasing, as in from fresh water to salt water, then the volume of water displaced must decrease. This is the reverse. When the change of density of water is increasing, as in fresh water to salt water, so from fresh water to salt water, your drop will decrease or your displacement will decrease. See? And your drop will also decrease. This is what it means if you go from fresh water to salt water. Because the tendency of going to from fresh water to salt water, the tendency of the vessel will rise up. So when it rises up, of course, the volume of your displacement will decrease. Because it is rise up, float, to rise up, your drop will also decrease. That is what it meant here. Okay? The amount by which a drop will either increase or decrease because of the change of water density where the ship is to float is called the change of drop to density. So that is what you call the change of drop due to density. So it's either you will decrease your displacement or increase your displacement, or your drop will increase in depth or decrease in its reading. That will be what you call the change of drop due to density. Okay, the ship officer must know how much his change of drop will be. Okay, given either the drop or displacement of the ship, the change in drop, either increase or decrease, can be found by one, using the fresh water allowance. We have already discussed this in the previous special, and using Dock Water Allowance. So we also discussed in the previous vessel, or using the formula change in drop to density equals displacement, meaning the present displacement times 1.025 minus the local density or the dock density over the local density or dock density times TPC of this current displacement and times 100, or using the hydrostatic tables. Okay, so find the new drop, apply the change of drop to all drop as if the change of drop is sinkage, meaning the vessel will sink because of increase in the displacement. So initial drop plus change of drop is your new drop. This is sinkage, guys. When you sink, of course, you will go down. The vessel will sink or go down. Since your vessel will sink, of course, you have to add the change of drop because you will increase in your reading of your drop. Okay, so that will be in your drop. If change of drop is to rise, meaning the vessel will float or will rise, so the initial of drop, you will deduct the change of drop from the initial drop. Then you will have a new drop. Meaning, if the vessel is going to rise, of course, the ship's reading of your drop will decrease because you are floating. So it will decrease. Your drop will be decreased and your displacement will also decrease. Okay, that is what it meant here. Then we go to this next figure. Change of drop due to density formula. So take note of this one, guys. The change of drop as in Dock Water Allowance can be calculated by change of drop due to density of water. The formula was displacement times 1.025 over uh, local density minus 1 over TPC times 100. Okay, meaning this one is the change of drop in meters. Or by the formula, change of drop to water density is displacement times 1.025 minus your local density over local density times TPC times 100. Okay, so where displacement, this one, is the present displacement, and DD, which is this one, is your dock water or new density, okay? Or your local density. And TPC is salt water. The TPC of your current or your present displacement, okay? So for calculator operation, the formula can be written as a change of drop due to water density is displacement times 1.025 minus your new density over new density times TPC times 100. Okay? So change in drop due to water density is applied to initial drop following the same rule as fresh water allowance and dock water allowance. So here's an example, guys. Example 3.5, change of drop calculation. So this is a Panamax vessel or 7-hold vessel is fully loaded to her summer displacement. Find the main drop if she's floating in water density of 1.2. So this is her summer displacement of this vessel is 13.25. So this summer displacement will be 78849. Okay? So 13 point what will be the summer displacement of the vessel? Let's go. Summer drop is 13.295 and his displacement is 78849. Okay? 78849. So this will be his summer displacement and this will be his summer drop of 13.295, which is this one. Okay? Summer is 13.295 and summer displacement is 78849. Okay? That is summer. And the change of drop due to density is displacement times 1.025 minus your local density over local density times TPC times 100. So what is the TPC of the summer drop? 295. Okay? Or your uh, TPC of displacement of 7849. So we 13.295, 13.295. Yeah, 13.295. The TPC is 6445. So the TPC is 6445 or 6.4. And the change of drop will be 0.157. So because you are going to go to density 1.012, meaning from salt water, meaning this means from salt water from salt water, you are going to fresh water for one, and the volume of your, if you're going from salt water to fresh water, your displacement will increase and your drop will also increase, which is this one, guys. So, from salt water going to density of 1.012, so you add this one. So your drop will also increase of 13.452. Okay, so you add this one, your change of drop in meters, you add to your initial drop of 13.25, and your final mean drop will be 13.452. Okay, we will check this, guys, by our program. So here, no, we just use this conversion of density. So your displacement, initial displacement of salt water was for 78849. Okay, 78849. So 78849. Put it here. 78849, and that corresponding displacement is how much? 13295. That will be 13295. 13.295, and the new density will be, how much will be the new density is 1.012. Is 1.012. Put here 1.012, and your new displacement will be 79862. Take note, guys, your saltwater displacement is 78849 because you are floating in a 1.025 or salt water. But if you are floating in 1.012, which is less of 1.27, your displacement will increase. Take note, your displacement will increase, or the ship's drop will also increase. It will sink because your vessel will sink. Your displacement will also increase, and your drop will also increase. So what is the drop of 79862? 79862. Okay. 79862. The new drop will be 13452. So 13452. The new drop will be 13.452. So take note, the displacement from salt water to your new density of 1.012, your displacement will increase. So that will be 79862, and your drop will also increase because you will sink. You will sink. So the new drop will be 13.452. Okay? And look at the figure here. Your new final mid drop will be 13.52. Okay? Which is the same. You can use this formula, change of drop calculation, or you can use this Excel which I made. So from salt water to dock water. So this is salt water. you're going to dock water or density of 1.012, and the result will be 13.52, which is the same with this one, 13.52, and the displacement will be increase in displacement, and your displacement is 79862. If you check the hydrostatic table, 79862, your drop will be 13.52. Okay, but look at the Excel program. You can also make a reverse here. You put the dock water density of 79862, which is the drop of 13.52, and now you're going to salt water. So your look at the formula. It is instead of 1.025, you put here 1.02012 over your salt water, and this one is the water. By transposition, then you have salt water of 78849, which is this one, and your drop will be 13.29, will be also the same. So this is a good program that which I made, which is give you a quick answer. Okay, so it is confirmed that the vessel has a new drop of 13.52. Take note, guys. The drop here will increase to 13.52 because you have a density of 1.012 from the saltwater density. Okay, so we go to the next problem. We go to MB Nara. Okay, MB Nara now will also going to float in 1.015. Okay, and what is the summer displacement of Nara and summer drop? We go to MB Nara and we go to capacity table. Then go down. The summer displacement of Evinara is 3844 and the summer drop is 9.55. Okay, so summer displacement is 3844. Got here 3844 and his summer drop is 9.55. Okay, check this one, 9.55. Okay, so with this change of drop, with this formula, displacement times 1.025 minus your local density of 1.015 over local density of 1.015 times TPC times 100. What is the TPC of the summer drop? TPC of summer drop, what is the displacement? 955. The TPC is 3546. 3546. We got here the TPC of 3546 and your change of drop will be 0.8. So 886. Okay, 886. You add this one because you're going from fresh water to the new density. So your vessel will sink. So you add this one. Then your final mean drop will be 9.636. And that will be your new mean drop. Okay. So we check this with the program. Your saltwater drop is initial displacement of summer displacement is 30844. 30844. Sorry. 30844. 30884. Is that correct? 308 30884, and the drop will be 9.9.55. Okay, and you're going to a new density or dock water of 1.015. Okay, let's confirm of 1.015. Okay, so what will be your new dock water displacement? That will be 31188. Okay, so that will be 31188. What will be here? Our drop 31188. 31188. New drop will be 9.636. 9.636. That will be 9.636. Okay. So that will be from salt water to dock water density. So your vessel, your displacement will increase if you're going to float in 1.015. Your displacement will increase to 31188, and your summer drop, which is 9.55, will also increase because the vessel will sink, and your new drop will be 9.636. Okay. Also, you want to reverse the formula, or you want to know the if you have a dock water displacement of 31188, and her drop will be 9.636, and you're going to float in a 1.025 of salt water, and your final salt water displacement will be 30884, which is the same here, and your drop will be 9.550, which is the same. So I prefer to use this formula or uh, program rather than I use this change of drop. Okay, because you have to get the TPC and so many calculations, but with the use of this program, you just put your displacement, your drop, your dock water density, and that's it. Then you will get your dock water displacement. Okay, so that's it, guys. If you like this video, please like and share and subscribe, and don't forget to click the notification bell. Thank you for watching and have a good day.